Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 3, Section 2, Solving Systems Algebraically. We use two methods to do this, and we learned this in Algebra 1. We use substitution and elimination, and in this video we're going to do a quick review of both of these. So I did put this into the words. Don't know if it's helpful, but maybe it'll help trigger your memory. When you solve things by substitutions, you pick one of the variables. You solve either equation for a convenient variable. Now I said convenient because I want you to choose one that doesn't make it harder. Maybe one that's not going to give you a bunch of fractions to work with. So you solve for one variable and then you substitute that into the other equation. Now this is very important because I've seen students solve one equation, a variable in it, and then they put it back into that same equation and it gives them like 16 equals 16 and they got nowhere. So this word other is very important. And then it gives us one equation with one variable that we can very easily solve. And then to find the other letter, if you have solved for x, then to find y, you plug in that number for x into one of the original equations and then solve for the other variable. So let's go through this and see if this refreshes your memory from Algebra 1. So I'm looking at my different variables that I have, and like I said, we want to choose a convenient one. For instance, I would not want to solve for this x here because if I'm dividing the whole equation by 2, I'm going to end up with a 5/2, and we don't want to make our life more difficult. So clearly this x with no coefficient is going to be the most convenient. So we're going to subtract a 2y from both sides. And now for the substitution, we're going to take this and we're going to go to the other equation where this x is. We're going to take this x out and put in this expression. So keeping that 2, putting in the expression 16 minus 2y, and then continuing with the rest of this equation, minus 5y equals negative 94. And now we know how to solve this. So we do the distribution, and we combine like terms and subtract a 32 from both sides. Negative 126, divide both sides by 9, and I believe y is equal to 14. So now we have one of the answers. We take this 14, go back to either one of these original equations and plug it in. I think I'm going to just choose the first equation. So I have x plus 2 times 14 equals 16. So multiplying by 2 and then subtracting the 28 from both sides, I get x equals negative 12. So the answer is an ordered pair, negative 12, positive 14. That's where these two lines would intersect on the graph, and this is the algebraic method to find those two answers. Now looking at this next example, I want you to remind you of something that you did learn in Algebra 1. If you make the observation that all these numbers in this equation are divisible by 3, you can do that. You can make these coefficients a little easier to work with. You can multiply an entire equation by a factor and you still have the same line, and likewise you can divide this equation by the same factor and it's still the same line. There's an infinite many ways to write the equation of a line, and we're just interested in kind of reducing this and bringing it down and making these numbers a little easier to work with. So I'm going to divide this first equation by 3, like I said, just to make my life easier. And then taking a look at this next one. Now this is a bit of a coincidence that 9, 18, and 15, they also have a factor of 3. It wouldn't have to be the same factor for both equations. You can reduce any equation if they all share a factor. So we just happen to have also a common factor of 3 here. So let's simplify this one a little bit. And now that I've reduced these equations, still the same line, we want to find where they cross. We need to select a convenient variable, and obviously this x has no coefficient, so that's the most convenient. So I'm going to add a 2y to both sides. So I have 2y minus 8. So let's take this value of x and let's go to the other equation where the x is, and let's substitute it in. Go ahead and do the distribution, combine like terms, and solve. And we notice something kind of peculiar happen. We have 6y minus 6y is 0, so we get negative 24 equals 5. And that is not the case. They are not equal. So this algebra brought us to a false math sentence. So when the algebra brings you to something goofy, I want you to think back to what you learned in section 1. Remember, it's possible that these lines intersect. It's also possible that they're parallel. Or perhaps we have one line on top of another. So we need to figure out what case we have here. So I'm thinking if the algebra brought us to a false statement, I'm thinking this could be a case of no solution, which would indicate these are parallel lines. So let's just check and see if our suspicion is true. Let's go back here and kind of mentally check the slopes here. If I added a 2y to both sides and divided by 2, the slope of this first line would be 1/2. So if I bring the 6y over and divide by 6, the equation of this line, the slope would also be 1/2. So what we have here is parallel lines, and there is no solution. They do not intersect. So just to repeat, when the algebra brings you to garbage, when this is false, they do not cross, there is no solution, they are parallel lines. The other method that we have for algebraically solving these is called elimination. I did put this into words. So to use elimination, you make any adjustments that are necessary so that when you add or subtract the equations to each other, one of the variables drops out. It's gone. Then you solve for the variable that's left, and once again, when you find the first one, you plug it in to one of the original equations to find the second one. So elimination involves a little planning ahead. So you're kind of looking at your x coefficients here. We have 2 and 3. If we wanted these to drop out when we added them, we could multiply the top by 3 and the bottom by, say, a negative 2, and then we'd have a plus 6 and a minus 6. So that's a possibility. If we look at our y's here, we have a negative 4. So if we had a 4y here, it would have to be a positive, and then the y's would drop out. So it doesn't really matter. You can decide whatever you are wanting to do. I'm going to choose to multiply this bottom one by negative 4. So the top equation remains the same. And notice how I'm lining up the x's underneath each other and so on to make the adding of the two equations easier. So 4 times negative 3 is negative 12x. And then I do have that positive 4y I planned for. And then I have a positive 32. So draw a line, add straight down. We'd get negative 10x, the y's are gone, equals 35. And now I have one equation with one variable, which is what I wanted. So I have a negative 35 tenths, which does reduce by 5. So I have negative 7/2. Please leave it in a fraction form and just work with it. We do a lot with fractions this year, and you need to be friends with fractions. So now take this negative 7/2 and then choose whichever equation you want. I guess I'm going to put it right here because I like what I'm seeing. If I multiply 2 times this 7/2, the 2's are going to cancel, and that's kind of nice. So I'm going to plug in my negative 7/2 to that first equation and then solve for y. Negative 7/2 times 2 is just negative 7. So now I'm going to add a 7 to both sides and divide by a -4. And so the y reduces to a -5/2. So my answer, again, it's an ordered pair, -7/2, -5/2. All right, one more example. And this also is going to review a skill that you had from Algebra 1. We're asked to solve this by elimination, and we notice that we have a bunch of decimals. Now you are welcome to work with the decimals, but you also can use that skill where you could multiply through by 10 or 100 or 1,000, whatever is needed, and you can get rid of the decimals. So in this first one, we have 2 digits after the decimal. So I'm just going to demonstrate this to you. If we multiply through by 100, we would end up with 13x minus 4y equals 120. And yeah, we have 2 numbers after the decimal here, so we're going to do the same thing. We have 117x minus 36y equals 1080. Again, your preference, you don't have to do this, but I just wanted to show that to you. So now we're going to proceed looking for elimination. So we have a 13 and a 117. I don't know, nothing is, I'm not recognizing anything there. But I recognize that 4 times 9 is 36. And I have a negative and negative. So if I choose, I could multiply this top equation times a -9 and make the y's drop out. So 13 times that -9 is -117x, and then it becomes a plus 36y, and then 9 times 120, I ended up with, I should say negative 1080. All right, this is kind of interesting now when I write in this second equation. So I hope you're kind of seeing what's happening. When we draw a line and add here, this drops out, the y's drop out, everything is gone, and we end up with 0 equals 0. Now what's different here, this math sentence is a true statement. It wasn't like 17 equals 42 or something. So we recognize this is something else. And if we look back here, there was kind of a clue. It should be a clue when these two are the same for each other except for a negative sign. What we have here is one line on top of the other. These are coinciding lines. So they share all solutions. So the way we would have to state this is by stating a line. And I usually go back to one of the original equations. So the answer is 0.13x minus 0.04y equals 1.2. And if this was on a test or something, I would have to accept any form of that equation. So you could say, you know, this first one is the answer, this second equation is the answer. Either of these two also represent the answer. It's just one line, and it's just ways of saying the same equation for that line. So now you've seen what happens with the algebra when you have parallel lines or coinciding lines or intersecting lines. And I think you have the knowledge you need to do section 3.2. So have fun with that.